Greetings, everyone, and welcome in to my channel. I am Professor L. This is a live stream for math help. So if anyone has a question about their math and they would like to post in the chat, they're welcome to do that, and I will attempt to answer it. And in the meantime, I am going to be presenting a topic on negative angles and using the unit circle. So I am going to go ahead and get into this and see how it goes. All right. So yesterday I spent my entire session graphing the tangent function. And we're going to move on from tangent. However, I'm not quite ready to move on from the unit circle because I realize that I need the unit circle to explain this concept called negative angles. Okay. And when you are dealing with negative numbers, see what's the best way to explain this. Kind of backtrack and talk about the number line for a minute. Because the Cartesian coordinate system is essentially it's two number lines. One number line is moving vertically and the other number line is moving horizontally. And, excuse me, sorry. My stool there is in my way. All right. So to kind of back up a minute and see if I can explain negative angles. Okay. So go ahead and title it. And I'm going to first just draw a little portion of my number line. So this goes back to elementary school years. We have 0 here. You have -1 here, and +1 here. To the right is positive infinity. We'll say plus infinity. And then we'll say this direction is negative infinity. And it doesn't look even, so I'll try and make it a little bit more even here. All right. So what we found in the number line is this distance from 0 to -1 you can represent that if you call this, it would be b minus a. So this would be a and this would be b. And then you figure out that the distance is the quantity 1, even though it's out to -1. And it's the same distance here as the quantity 1. 1 plus 1 is 2. So this entire distance is the quantity 2. And you would find that the old distance formula if you wanted to use an official formula, you'd say it's the absolute value of b minus a. And then you draw another portion of the number line here. For example, if I'm at -2, -1, 0, 1, and I'm on -2, and I want to travel to 1, I would call this value A and this value B. And so to determine this entire distance using this formula, I'll plug in my values and evaluate the absolute value. That's what these bars signify in math, is the notation for absolute value. And what absolute value is it's the magnitude of the number. It's the size, the amount of the number separated from the negative, okay? And so I will plug in my formula. B is the quantity 1. And that's minus, because the form says minus. And then my A is -2, so that I include an extra negative with the parentheses. And then I evaluate this absolute value. Oops, forgot the negative. And remember, 2 negatives make a positive. So this would be the absolute value of 1 minus -2, which is 1 plus 2. And then you end up with the absolute value of 3. And the absolute value of 3, remember, absolute value is always positive. It takes positive and negative values, and it only returns positive values. So this one is the quantity distance 3. And intuitively, we already could see that because we traveled 1, 2, 3. And so why do we have this thing called the absolute value? Okay. Absolute value is because we have that, and it's very important, especially concept in physics, where we have to be able to, in our math calculations, represent the number's amount, its quantity, its distance from the origin, separate from its direction. And so if you notice on this number line, let me go ahead and erase some stuff so it doesn't, this looks like a funny abstract picture now. So I'm going to erase this and go back to this number line up here. And what the absolute value represents is the distance on the number line from this 0 point. All right. So -1 has a distance of 1, but it's the negative direction from 0. So all of this, the only thing that this negative is good for is direction. Okay, that's all it is. So the negative is helping us in mathematics keep track of the direction of the number. Where is this number existing in relation to 0 on the number line? And in upper level math, we put those number lines together and we create a grid, a coordinate system, where it's literally just 2 number lines. You have a vertical number line, that's the y-axis, and you have a horizontal number line that is the x-axis. Okay. And the origin is where they meet. To the left of the origin is negative values, and to the right of the origin would be positive, and vice versa. And it's more intuitive to think about up being positive and down being negative, I mean, in my opinion. But that's the reason why we have absolute values, because the magnitude, the quantity, the amount, the size of the number is just as important as, or sometimes we have to have just the size, and the direction doesn't really matter. I mean, it matters, but it's not, it's like we have to be able to distinguish the two. Because math, there's a lot of details. All right. So with that being said, negative angles. So when you have a coordinate system and you graph the circle, and you graph this circle, it's okay, I'm gonna erase my infinities because I realize that I want to keep it as simple as possible. Math gets really complicated, so try to keep it as simple as possible. Okay. And what we're doing is we're graphing this circle. It's x squared plus y squared equals 1. where it's centered at the origin with the radius 0. So we have the center is 0, 0, and you have, oh, it's little r, sorry. Radius is little r. It's radius of 1, okay? And we graphed the circle many times, but we're going to graph it one more time and talk about negative angles, okay? So here we go. And use this unit circle to do it, okay? And I look on screen and I notice how bad it is, and if it's really bad, I gotta fix it. So I don't know. One of the quirks in my personality, I guess. It's really important to get an accurate sketch. All right, see if that's a little bit, that it's just gonna have to be good enough until I get more comfortable writing on this board. It's been a while, so I need to just not spend the entire hour trying to get the circle perfect. I'm gonna do one more time and then I'll give up, okay? I promise. All right. All right, so, okay. All right, this is gonna have to work, and then we're gonna go ahead and redefine these values. So recall, this is the 0 degrees, this line right here. And at this starting point, we don't have a reference angle, or we have a reference angle, it's of 0 degrees, because it's right here laying on the x-axis. And then we also have a value of 2 pi. Because if you travel exactly around the circle one time, you go full circle, you have gone 2 pi. And 2 pi in radians is 360 degrees. And then up here was pi over 2. Let me go ahead and box this so it's not in my way. And then we established that this was pi over here. Okay. And then this was 3 pi over 4. I mean 2, excuse me. Oh, I wish I wouldn't say things wrong, but this is 3 pi over 2. Okay. And so what we talked about was all of these other values. So I'm going to go ahead and just put them in really quick and see if I can do it. That was pi over 6. Pi over 4. And then 60 degrees was pi over 3. Well, counterclockwise, this direction is considered a positive rotation. That's plus positive. It's a positive rotation, okay? And it's producing all of these values. But there's also, in math, there's a negative rotation. So if you go clockwise, all right, you go clockwise, then clockwise is considered a negative rotation. And that's where they're getting those negative angles, okay? So if you go clockwise 90 degrees, this is negative 90. So this is negative pi over 2 here. Okay, in the positive direction, it's 3 pi over 2, but the negative direction becomes negative pi over 2. All right? And then pi is still pi, but it's also negative pi. So it's both of those values. Okay. And then similarly, adversely, pi over 2 will become negative 3 pi over 2. Okay, both of these. both of these, and 2 pi. So if you go all the way around completely, you've also gone negative 2 pi out here. So this becomes all of those. And then similarly, inversely, also, this value right here, as you would suspect, becomes negative pi over 6. This value here is going to be negative pi over 4. And then you've got one more value here. This is going to be negative pi over 3. Okay. And I'm going to go ahead and fill these in this quadrant, and then these are the only quadrants we really need today. I don't know if I want to go ahead and, just because the circle's going to look weird if I don't finish it, but maybe I have my picture of my unit circle up so I don't have to sit and drive all these. I don't have it memorized yet, and it bothers me, but I'm hoping that if I continue working on this math every day diligently, that soon I will have it memorized again. The unit circle is to upper level math as the multiplication table is to lower level math. So it's very, very important. And a lot of these math majors will have it memorized because you use it so often. Okay. All right. So we've got this angle right here is 2 pi over 3. This one was 3 pi over 4. 5 pi over 6. Go ahead and get these real quick. And then I'm trying to think if I know for sure to graph the inverses, I need at least negative to negative pi over 2. So we might not list all of the negative angles. Yeah, I just don't know if it would be relevant. It's a lot easier to present the math and work with the student if I have like real students and I'm explaining something to someone in person. It's a lot easier because what's happening is I'm meeting them where they're at, and I'm able to, ask questions and engage in dialogue with the student to figure out where they're at and where they're missing their understanding. But if I'm just up here blindly teaching, and I'm literally just teaching to a lens, I kind of struggle a little bit to figure out, like, okay, what do you need to know? So it's a lot easier if I have someone like, hey, Professor L, blah, 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 what about this? And then I can go ahead and answer. But it's okay. I'll just kind of play it by ear and see if I can figure it out. And all this is really for fun anyway, so I don't think I'm gonna, it's a win-win essentially. All right, so let's go ahead, and this was pi right here. That was 7 pi over 6. And we've got 5 pi over 4 and 4 pi over 3. And then I'm going to not list the negative angles because I just need them for the first and fourth quadrant. All right, so basic introduction of negative angles, okay? See essentially what's going on here. And the reason why I needed to introduce the negative angles is because I wanted to start talking about the inverse trig functions. And because the inverse trig functions exist and they're kind of tricky, there's a couple of other topics that I kind of have to talk about. And one of them is what makes a function a function. Um, Functions are specific. Not all relations in math are going to be a function, but if it's a function and it's a one-to-one function, then it will have an inverse. And if it's not, there are functions that are not one-to-one. And um, if it's not one-to-one, sometimes you can restrict the domain and take a chunk of the function and find the inverse. And so that's kind of what we have to do with the sine and the cosine. Well, all of the function, all the trig functions. So that's kind of what we have to do. So what I'm going to do is, since I went ahead and kind of briefly introduced the negative angles, I can go ahead and sketch a graph that's more symmetrical about the origin for the sine function, and see what's going on and show you kind of more a picture of what I just said. So we need to have some negative angles and negative values here in order to do that. So we're going to go out. Let's see, we got the origin there, and we're going to try to go out to 2 pi both directions. Yeah, so I might have to go ahead and put the negative angles in here. Getting ahead of myself. So we'll go out to negative 2 pi. And I'm going to pause there, and we're going to go back and find all of these negative angles, okay? And the process is similar. It involves, all I'm going to do is I'm going to use the mirror image. And so over here, if you notice, we've got pi over 2, negative pi over 2. And then here is negative 2 pi over 3. So I'm going to cheat a little bit, and I'm going to say here is negative 2 pi over 3, because I'm in the, see, that would be quadrant 2. So I'm going to circle it. 5 pi over 4 would be negative 3 pi over 4. And then 7 pi over 6 would be negative 5 pi over 6. Negative 5 pi over 6. And then we're at negative pi. And then we would be here. It's like the second and third quadrants are flipped. So let's see here, 5 pi over 6. And then I would be right after pi, I'm at negative 7 pi over 6. Negative 5 pi over 4. And then negative 4 pi over 3. And then I'm at negative 3 over 2 pi. And then I'll go to the fourth quadrant. Oh, I didn't list the fourth quadrant here. I only have the negatives. So let me erase the negatives here. List these values in the fourth quadrant real quick. That was 5 pi over 3. And then that was 6. 7 pi over 4 and 11 pi over 6. Okay. All right, good. So I'll go ahead and erase this so I can write these other angles in. All right. Negative. This was negative pi over 6. This one was negative pi over 4. And this one was negative pi over 3. And then, hang on, did we do? Okay, this is the fourth quadrant. So we've got negative, look what I did. So this is going to be negative, what, 5 pi over 3, circle it. This would be negative 7 pi over 4. And this one is negative 11 pi over 6. And again, there's plenty of, I mean, it took me a couple of like searches to go and actually find the unit circle that has the negative angles, but they're out there. And you know, you don't need me to draw you a picture. My picture, it looks pretty bad, but I'm just using it to as a tool. And you know, who knows, sometimes maybe people like to have things, you know, explained to them a little bit. Okay. All right. So I have my values now for my negative angles, and that's going to help me partition my graph for a sine function. And so recall the sine function, and I'm not going to use, let's see, we're going to go ahead and partition it this way. So we've got pi, and then this is negative pi. And I just realized that I didn't necessarily need to do that because I'm going to have, I don't know. Okay, so I think I'm going to have enough points here. So this is pi over 2, got negative pi over 2, and we've got, this is 3 pi over 2, and then this one would be negative 3 pi over 2. So it's like, it's a symmetrical graph. And what's happening is we're going to go ahead and sketch the graph of the sine function. Y equals sine x. And remember or recall that the sine function is it's a periodic function where it has repeating values. It's cyclical. And that's the reason why we're able to derive its values from an equation of a circle. Okay. So we're going to go ahead and sketch this function, and we're going to kind of do it in depth because recall, it's good practice to go ahead and build a table and do it the old brute force method where we get to see what we're doing. How am I finding these values? Okay, so let's do it over here. You have a table of values for the values that you want to pick for your domain, in your domain. So you've got your x values, and this is your independent variable, and then y is your dependent. So y is going to depend on what x is. So the game for graphing functions, or graphing any relation or function really, is you select values in the domain, and then you plug into the function, evaluate the function, and then it's going to give you an output. It's going to tell you the behavior or the nature of the graph. So the values that I'm picking here, I'm going all the way out from negative 2 pi all the way to positive 2 pi. So I'm going to list all these values in order from least to greatest. Okay. So I've got negative 2 pi, negative 3 pi over 2, negative pi over 2, 0. And then we've got positive pi over 2. And then our looks like it's going to continue. So we've got a continuation of the table. I'll go ahead and do pi over 2 here. Pi over 2, pi, 3 pi over 2, and 2 pi. So when I go to negative 2 pi, what we're doing here is we're taking sine, which is opposite over hypotenuse, and we're going to evaluate. Oh, I don't need the triangle. We're just doing the four corners. Hang on. Sorry. So I've got my four corners, and over here, at this point right here in the unit circle, these are the only points I'm using. So we've got 1, 0, and we've got 0, 1, negative 1, 0, and we have 0, negative 1. So sine, remember, it is the y component for your order pairs. So recall that this was 0 degrees and 2 pi and negative 2 pi. So all of those values right there, I'm going to plug in 0 for sine. So negative 2 pi, I've got 0. At 0 degrees, I have 0. And I also have 0 at positive 2 pi. And then we're going to go to the pi over 2. And the sine at pi over 2 is 1. So remember that this is also negative 3 pi over 2. So at pi over 2, I have a quantity of 1, and negative 3 pi over 2, I have a quantity of 1. Okay. And what's the next value? We've got this one. We're going to go over here and figure out what's going on at pi. Sine of pi is 0. So at pi, it's also negative pi. So we also have these 0 values, pi and negative pi. A couple more, we're almost done. Looks like I have negative pi over 2 and 3 pi over 2. So over here at negative pi over 2, 3 pi over 2, I'm down here. And looking at the sine value, it's negative 1. So negative 1, negative 1. And really, you can look at a table of values of a function and determine whether it's a function or not. It has to do with the values in the domain and range. And if there are no repeating values in the domain, then it's a function. However, it has to have a 1-to-1, so there cannot be repeating values in your domain or your range for it to be a 1-to-1 function, for it to be invertible. So what we're doing is we're taking all of these ordered pairs and we're going to plot out the points for our graph. And we're going to start over here at negative 2 pi, and we have a 0. And if you have these repeating values, see how there's 0, 0, 0. If you have well, we'll just go ahead and graph it and I'll talk about it, because I think a picture is worth 1,000 words. So negative 2 pi and then negative 3 pi over 2. I put 1 here. 1 and negative 1. 3 pi over 2, I'm up here at 1. And then negative pi, I'm back to 0. Negative pi over 2, I'm at negative 1. Down here. And 0, the origin. And then pi over 2 is positive 1. And then pi would be 0. And then 3 pi over 2 is negative 1. And then 2 pi is back to 0. Okay. So now I'm just going to connect the dots and draw out my function. And what I've done is I've mapped out 2 full periods of this function so you can see the behavior of the function. And so there is this thing called a vertical line test to initially establish whether it is a function or not. And what you're doing is you're just drawing vertical lines in your function. Imagine a bunch of vertical lines. And what we're looking for is if there are if one of these values for your domain is leading to multiple values in your range. So, and it's passing this test. There's nowhere in the domain of this function that's going to produce 2 outputs in the range. Because if the vertical line touches the graph more than once, then it's going to not be functional. But since that every value in the domain gives a different value in the range, you can have repeating values in your range, but you can't have the repeating values in your domain. Okay, so it passes this vertical line test. However, it does not pass the horizontal line test because you can see, like if I'm to test to see if it's a one-to-one function, it's going to fail every time there's a repeat in the graph. So it's leading to multiple values in your range, and it's failing every time there's a repeat. So what we're doing is we're taking only the unique values. And so it turns out that they cut it off right here at pi over 2 because of these repeating values here and here. You can't have 2 values in your domain. You can't have multiple values in your domain and have it to be invertible. To be able to find the inverse of that function. So what we're doing is we're taking the sine function and we're going to restrict the domain where we're only going to use this chunk. Okay. We're only going to go from negative pi over 2 to pi over 2. Okay. And I knew that I was going to need a bigger board. And when we do that, we'll sketch another graph here. And this one's a decent size. It's taking up the majority of this wall. It's still not big enough. All right, so what we're doing, we've got 0, your y, and your x. And we've got negative pi over 2 and pi over 2. And then if we wanted to list a couple more values, we could, but and we're gonna, at negative pi over 2, we were at -1 down here. And we got 0. And we have pi over 2 is back at 1. So here is this is sine x, y equals this kind of thing. So we're going to restrict the domain between negative pi over 2 and pi over 2 to draw out the inverse of sine x. And I realize that we might not get to draw this out today because I really want to draw out. I'm going to back up. And so we've got an understanding of what we're going to do here. And I realize it took me a long time to explain that. But what we're going to do is we're going to leave that portion up. I'm going to erase this, and we're going to talk about cosine real quick while I have these negative angles up. And then I will try to sketch this out or maybe possibly leave it up so I don't have to waste so much time redrawing it. All right, cosine is slightly different, okay? So we're restricting the domain of the sine function here. So we can calculate the inverse, okay? Because it's only invertible from the period of the non-repeating values, okay? So as soon as you have a repeating value in your domain, you're not going to be able to invert it. All right, so cosine, even though it has the same period as sine, 0 to 2 pi, because of how the graph, I'll just erase all this. And we'll come back to that restricted domain and we'll pick up there tomorrow. But I'm going to go ahead and we're going to look at the restricted value and the cosine. Okay, and just try to explain to you why why are you restricting the value? What's the point of that? And again, if it's a cyclical function and it's going to lead to multiple values in your domain, repeating values in your domain, it may be a function, but it's not going to be a special kind of function that's going to have an inverse. Okay, so you really, for it to be 1-to-1, you're not going to have repeating values in your, and it is kind of a complicated concept for people, especially if you're not really invested in math, you're just trying to get through it to get on to the next thing. It's a prerequisite for a lot of classes in college, so a lot of people just take the math and get through it and then want to just dump it in the dumpster as soon as they're done. But then some people like the math and they work on it for many years. And it is kind of a meaty topic. I don't need the negatives. So we're going to erase sine. So I'll do my best to try to just explain it briefly and not really get into it. But then again, that's probably also really hard to do. So 1, 0, I erase that. That's 0, 1, -1, 0, and 0, -1. And I want to go out to 2 pi, -2 pi then. But it's not even really necessary. But to get 2 periods of the graph, I really want to do it, and it's good practice for me. So we've got pi, -pi, pi over 2, 3 pi over 2. This is negative pi over 2. And one more here, negative 3 pi over 2. 1 to negative 1. All right. And remember with cosine, what we're doing is we're looking at the x component. So we're going to go ahead and build our table. Let's see if I can put a table in right here. Get all those points in there. Good. And I hope that everyone is not getting bored with the graphing of these trig functions. I know I'm not, but if you are, let me know. I can move on. Math is such a broad subject. There's so many different kinds of maths. I probably could host a live stream for many years and, you know, talk about math and not even touch the surface of everything. You know, it touches so many different facets in life. All right, so we're going to start out our lowest value first is negative 2 pi. And we're going to list all of the values that we want to evaluate in our function in the domain here. And we're going to start with the smallest value. And we're just going to go in ascending order. And 0, pi over 2, pi, 3 pi over 2, and see if we can fit this 2 pi in here. That way I don't have to make two tables. So we've got negative 2 pi over here. So this is 0, 2 pi, and negative 2 pi. And my my x component is 1. So I've got 1 here. And I've got 1 at 2 pi, and also at 0 degrees, I have quantity 1. 3 pi over 3. This is 3 pi over 2. Silly me. All right. So at negative 3 pi over 2, we're right here at pi over 2. So here, my cosine value is 0. So negative 3 pi over 2 is 0. And you can already see by the table that this is not a one-to-one function because you have different values in your domain and they're pointing to the same value in your range. In the range. So we've got, now we're going to go to negative pi, and we're out here. And looking at the cosine, it's at negative 1. So at negative pi, it's negative 1, and it's also negative 1. All right, 0. And pi over 2. Yeah, how did I miss negative pi over 2? Here. Cosine back to 0. All right, so I think I have them. And we'll go ahead and sketch our points real quick. So negative pi over 2, I'm at positive 1. And negative 3 pi over 2, I'm at 0. Negative pi, I'm at negative 1. Negative pi over 2, I'm back to 0. At 0, I'm at positive 1. And then pi over 2, I'm back to 0. Pi is -1. And 3 pi over 2 is back to 0. And 2 pi is back to +1 here. Okay. And we'll go ahead and sketch this graph of the cosine function, just connecting the dots now. Let me connect the dots. And I got lazy with that one. So and we've got this kind of thing going on. So we're starting here, and we're going to go ahead and do the vertical line test, and it passes the vertical line test because for every value in your domain, okay, there's no repeating values. It starts from -2 pi. You don't see -2 pi show up in the list anymore. And so each value in the domain is unique. It's different. And you can have repeating values here in order for it to pass the initial test for a function. Okay. It's that vertical test. Like there's no repeating values in your domain, then it's functional. However, to see if it's a special kind of function, if it's invertible, there has to be no repeating x's and no repeating y's. So if you have, so you do the vertical line test, and you see immediately here it's failing because you have multiple values here. Okay. You draw a line in your domain, like you draw a horizontal line, and if it touches the graph more than once, then it's not a 1-to-1. It's not going to be 1-to-1, so it's not invertible. That means that you can't find the inverse. So what they've done is they've restricted the domain. So they've taken the values at some point where it's not going to repeat. And so what they've done is from 0, let's see, we can't use 3 pi over 2 because you have 2 of those values. You can't use 2 pi because you have those values. These values are the same. So what they've done is the math people that studied this and figured all this out a long time ago, is they've taken and they're going to restrict the domain at 0 right here at this point, and they're going to restrict it here at pi. So it's just going to go from 0 to pi. And so we're just going to take that chunk, and I've been writing with the same marker for 2 weeks, and it's finally starting to go on me. I guess it's a good one. It's been good to me, but it's finally starting to do its thing. And just those markers, they don't last forever. They just dry out. But we're going to take this chunk of the cosine graph so that we can calculate the inverse of it. So we'll go ahead and resketch it here. And I'm going to go ahead and erase this table of values. And even though math is really complicated, if you work on it long enough, I mean, human beings are highly intelligent and highly capable of figuring things out, and anybody can do the math. I would argue that we have a genetic predisposition to understand the math. because math, what it represents is what man understands. It's man's understanding, and it's an accumulation of knowledge through all of the generations, and every generation contributes to the knowledge. And so it's an accumulation of what we've accomplished since we crawled out of caves and started thinking about things. Okay. But we're gonna go. Actually, I don't need both. And we're not even dealing with tangent today, and I'm on a tangent. Not on purpose though. So we've got 0, and we're just going out to pi. 1, -1. And the time's getting ahead of me, but I'm gonna go ahead and sketch it real quick, because next time, if I don't have anybody that's asking me questions and I don't have a tutoring session here, then what I'll do is I will graph the inverses tomorrow. So, because I think I've pretty much got everything set up to do that now. So we've got y and x, and then we've got pi over 2 with 0, and then pi was -1. So we have this thing. This is y equals cosine x with a restriction in its domain. So we're saying x is from 0 less than x less than or equal to pi. Let's see if I can spell it correctly. Restricted. Okay. And hopefully I did okay explaining why we have to restrict the domains of the sine and the cosine function to find their inverses. And so I'm going to go ahead and stop there. That went by really fast for me. I hope that it wasn't too mundane and repetitive. But again, I am very excited to be here, and hopefully eventually I'll be able to support some students through their math through this platform. And if not, it's a really good experience for me to develop a skill to talk to a camera, and just be personable to a camera. It's challenging. So thank you so much for watching and tuning in, and I will be back tomorrow between 6 and 7 p.m. Central Time, right here to continue this project. So again, I'll see you all next time.